First concept to take a look is syllogism. Basically, this is an argument of type if A then B, if B then C, therefore if A then C. For example, Socrates is a human, and a human is a living organism, so sooner or later it will die. Therefore, Socrates sooner or later will die. If we want to prove something, we use either direct proof methods or indirect proof methods. In here, let's take a look at three direct proof methods. Proof by deduction, proof by induction, and proof by exhaustion. Basically, proof by deduction is a chain of syllogisms. A therefore B, B therefore C, C therefore D. We can continue. Therefore, if A, then D. For example, if I live in Toronto, then I live in Ontario. If I live in Ontario, then I live in Canada. If I live in Canada, then I live in North America. Therefore, we can conclude that if I live in Toronto, then I live in North America. Another method of direct proof is proof by induction. Basically, in here we examine elements and then we make our conclusion. For example, I see a swan and it's white. Okay. I see another swan, also white. I see another swan, also white. So then I say, oh, then let's conclude that most likely all the swans are white. This will be proved by induction. The third method is proof by exhaustion, and this is basically a subset of induction where we examine every element or every case. For example, if I were to examine every swan on the planet Earth and I see that it is white, then I conclude, oh, okay, then all the swans are white. Indirect proof. In indirect proof, we basically assume that opposite to our conclusion is true. Then we proceed with our deductions and we try to find a contradiction. So if no contradiction, then our deductions are consistent. If we find contradiction, then we have inconsistency. Therefore, we come back and we say, oh, then our original statement with that we said that conclusion is true is actually true. Another useful concept, a little similar to indirect proof, is disjunctive syllogism. We say if either P or Q is true. For example, if a lizard is in a room P, or maybe sorry, it is in a room Q, then we randomly choose to examine one of the rooms, and we examine room Q and we see there is no lizard in room Q. Then we conclude that, okay, then therefore the lizard is in the room P. And here we use the concept of disjunction. Disjunction means either, like for example, if we solve a quadratic equation and we get two roots, so either of those roots is good to go. So we have a disjunction of those roots, and its concept is similar to, sometimes we say, union. Conjunction. It's like disjunction versus conjunction. Conjunction is when both conditions, we must meet both conditions. And this concept is similar to intersection. For example, if we take a quadrilateral and we take only two opposite sides, one pair of opposite sides, two opposite sides, and we say those opposite sides are parallel, can we conclude that that quadrilateral is a parallelogram? No. Why? Because yes, it is necessary for opposite sides, for two opposite sides, just two, to be parallel. It is necessary, but it is not sufficient. We need another conditions. Those two sides, those two opposite sides in one pair, in addition to be parallel, they also have to be equal in length. So now if we have two conditions met, both simultaneously, we have intersections or conjunction of those conditions, then we can say, okay, then it is sufficient that a quadrilateral that has in one pair of two opposite sides, both sides are parallel and at the same time they have equal length, then that quadrilateral is a parallelogram. To visualize our deductions and our logic in geometry, we use Euler diagrams or sometimes Venn diagrams. Basically, Venn diagrams, they must include all the possible intersections, even if those intersections are empty sets. Euler diagrams are simplified version of Venn diagrams where we can just omit intersections that are empty sets. And another concept is premise, which is similar to what we discussed, hypothesis, and which is similar to assumption, and sometimes we can even say a postulate.